All right, here we go. KK, you get to lead us today. Number 1. 6 more than twice a number. What am I doing? First of all, KK, tell me what more than means. Plus. So I want you to put a plus right above it. Now, your problem is it 6 plus or is it plus 6? That is correct. Wow, KK, good job, girl. Come on, it's not that hard. All right, it's not that hard. Okay, Molly, you're up. Number 2. How do I do that? Yay, okay, I feel progress. Good job. All right, Jolie, read. Okay, so what about this? What's quotient mean? Do you know? Divide. 2 over y. Now, here's where I need you to think, even though it's not wrong, is 2 over y being added or is -7 being added? So the quotient of 2 and y is added to -7. Yeah, now look, I keep trying to tell people, right? Does everybody understand that there's just nothing I can do on that? All right, I want everybody to read that again. And I want to make sure you can see that translation. -7 plus 2 over y. Come on, KK, you did good. All right, is everybody good with -7 plus 2 over y? Hey, concentrate now. All right, big test on Friday. Anybody have any issues with that? All right, here we go. What? Okay, that's possible. Yes, I'm not arguing with you, right? But in this case, is referring to what's happening to this and to -7. Does that make sense? And like I said, it's just hard, right? It's hard. Okay, next. Thank you, thank you, thank you. 12 minus 11y. And just like Luca did, if you're not sure, I want you to tell me. How's that? Seems better today. All right, Avery. Now, quantity, I want everybody to highlight quantity. If you forgot, that's your parentheses. Parentheses. Right? X plus 3. You with me? All right. Yeah, and again, guys, again, a little better every day. All right, that's kind of tricky. All right, where are we at? Ashley. So what is that, kiddo? Oh, hold on. Say it again. -1. I didn't hear you. Plus x over 4. Perfect. 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 All right. Everybody's now understanding quotient. All right, next.
10 times, what's the difference?
Come on now, think about it. If you don't know, take a guess. Subtraction.
All right, so 10 times negative 5x.
All right, first of all, everybody needs to highlight this for me now. Times difference. That's two operations in a row. Do you agree with me? What did I tell you you need when two operations are in a row? You definitely need parentheses. All right. So now start again.
10 parentheses.
10 parentheses. Now difference means what?
Subtracting.
So what two things are we subtracting?
X and y.
That's correct. So X what?
X minus 5.
And then close parentheses. All right, I'm pretty happy with that. Okay. Next, Cole.
7 increased by 4 times the number of y. Oh, it's 7. And, oh, minus or negative 4y.
Yes. All right, I'm pretty happy with that. Pretty happy. All right, come on, Eddie, help me.
4 times the sum of the non-f. So it will 4 times plus 8.
So close. But now look, I need you again, everyone. I'm trying to give you a clue. Times and sum. What does that require? Because there's two operations right next to each other. You with me on that? So 4 times the sum. So now tell me.
So 4 and then do plus 8.
That is correct. F plus 8. That's it. All right. These are all expressions. They're different from yesterday. Yesterday was equations. These are expressions. We'll get to the equations in a minute. What?
Want me to do next?
Yes.
Arena was 3 years old 6 years ago. How old is the arena today? So just D plus 6.
Yeah, D plus 6. All right, D plus 6. All right, next. Zeb.
Travels x after 45 seconds. It
Yes, good, 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 good. 45x. All right, I'm pretty happy with that. All right, KK.
30. Oh, 30.
Yes, all right. 30p. I'm pretty happy. Okay, now you got to be careful. Tell me.
X plus 6 plus 5.
So again, now listen to me, kiddo. I'm not saying you're wrong because I haven't even figured it out yet, but who's taller? Yes, Laura is taller, right? So if Laura is L, they're telling you L, that's how tall Laura is. What's Sam's height going to be? Shh. No, we're making it with respect to L. Not X, it's got to be L. Now, is Sam taller or shorter? So are we going to add something to her height or subtract something? And what are we going to subtract? How much? That is correct. Now, do you understand how they're trying to trick you? Because it says Laura is 5 inches taller than Sam. Do you agree? But they're asking about who, though? They're asking about Sam. So Sam is whatever Laura is minus 5. Do you agree with that? All right, Jolie, go. Luke has $100 more than Rhonda. Rhonda has R dollars. Then Luke has what? Yes, R plus 100. Remember, as we're doing this, I was hoping, write it down. All right. Now we're just practicing the order of operations. All right. So we're going over here. Reese, what am I doing?
9 minus 4 is 5 times 3 is 6.
No one's using a calculator. 15. Good. Now I'd like everybody to just go ahead and put 5 times 3 just to make sure. Avery, what am I doing on 16?
7 plus 9.
Yes. All right, I'm pretty happy with that. All right, continue on. What am I doing over here? Beautiful. All right, I'm feeling pretty good about this. All right, Luca.
9 times 3 is 27. 42 minus 27 is
Mental math, 42 minus 20 minus 7. It is 15. All right, it is 15. Okay, here we go. 19, what am I doing? Which is 6 times 10, 6 times 5, added together. Shh, I don't want to hear it from anybody else. I want him to do it. What's 6 times 10? 6 times 5. 30 plus 60. 90 plus. What's 9 times 10? 9 times 2. 90 plus 18. 90 plus 18. I didn't hear you. Yes. 108. 108 plus 90. 198. All right, Eddie, what am I doing first?
25 plus 66.
And what is that?
91.
Good job, buddy. And then what?
35 divided by 5.
Which is?
7.
Uh-huh. Now do your mental math on that. 9 goes into 7. How many left over?
2.
What I did. So now 7 goes into this number.
Oh, I'm going to 7.
7 can go into that number. How much? Do you see what I'm doing up there? Can you read that? No. Look what I'm telling you. 91. 91 divided by 7. 7 goes into 9. How many times? How many left over? Now notice I'm putting a 2 right here. So then you're reading this number right here. What's this number now?
1.
No. Do you not see where I put the 2?
Oh.
21.
And it goes in 3 times.
That's right. That's why the answer is 13. Did you understand? You didn't understand that very much, did you? All right, let me show you again. Look up. Everybody look up. You need to practice dividing mental math in your head. Look up, look up, look up. Everybody's looking up. I'm going to make a couple more problems for us. So if I said 6 into 84. Eddie, no. Pencils, hands down, eyes up. How many times does 6 go into 8? How many left over? So then you put a 2 in front of the 4 and make it a what?
24.
Right. So now 6 goes into 24. That's how you do the division. Right? All right. Let me see. 98 divided by 7. Molly, how many times does 7 go into 9? How many left over? 7 goes into 28. Come on. 4, 14. You see that, Molly? Right? Does everybody see what I'm doing about that long division where you can do division mental math, right? Everybody's good? Review? Eddie? All right. Oh, you got a good one. Jackson. What's 3 to the 4th?
3 times 3 times 3 times 3.
Which is what? Mental. Don't write anything down, guys. You're not trying to write anything down. You're no, I know. I'm saying everybody in general. I know. I see you. Now watch. 3 times 3 is how much? 3 times 3 is how much?
Oh, 81.
Right. There you go. 81 plus what's 4 squared?
4 times 4.
Which is?
16
All right. We talked about this. 7 to the 0 power.
is 0.
Anything to the 0 power
It's 1.
is 1. And then what's 1 to the 4th?
1 times 4. Or 1 times 1 times 1 times 4.
Which is
1.
1.
So the 1 plus 1 and the minus 1 cancels out. So
That's
it's
better.
14 plus 16.
Which is? Come on, come on.
97.
Yeah, 97. Okay, 97. No, face the front. That's why you're up here. Okay. No. Tyler. Shh. Tyler, go.
So yeah, so on the bottom exponents.
Right,
So it's just 2 times 2 times 2, which is 8.
right.
And at the top, multiplication, so it's 10 and plus 54 is 64. And it would just be 8.
Yes, I'm good with that. All right, Zeb, you're up now.
I know what you
Okay.
do.
Come on, you're good with this. Come on, division. What did I tell you to do with division? Change division to what? Shh. And do the what? And do the what? Yes, reciprocal, we say. So 4/5 changes to what? Right. Okay, now what am I doing? Yes. So what can I do for those fractions? No, not common denominators for adding and subtracting, only as common denominators. We're reducing, cross reducing. So what am I reducing? How does the 4 and 3 reduce? What's reducing? What does that become? What? Yeah. So now what's 3/1 times 1/4? Yes. Now go to the next multiplying fractions. What can I reduce on this one? That becomes a, and this becomes a, okay, now what about the 5 and the 15? Okay, so plus what? Yes. All right. So far, so good. Now we have to add, so we need a common denominator. What's the common denominator? I don't think so. 9, 18. Does 4 go into 18? No. Next. Does 4 go into 27? Next. Yes. So the common denominator is? Okay. What do I multiply the first fraction by? Yeah. Remember, I'm trying to get a common denominator of 36. Multiply by what? Yes. So 3 times 9. Good. 9 times what is 36? Yes. Now 27 plus 4. Over. There you have it. All right, that's a review of fractions, right? If you got that right, you're in pretty good shape with the fractions. All right. Dividing is multiplying by the reciprocal. All right, KK, you got your work cut out for you, kiddo. Come on, no fear whatsoever. Okay. First, I see, what do I need to work on? How do I handle that? Keep facing the front. I don't want to have to look up and down at you. You're up here for a reason. I can put you closer. What do I do, KK? Yep. Yes. Make it a what? And the other 6? Yes. So now I have what? Multiply those together. What do I get? Right. Now, what do I do with division again? Right. And division becomes what? And then what do you do with 3 over 1? Yes. Good job. Okay, so now what happens to this? No, because we're multiplying. No common denominators for multiplication. Can you reduce anything?
Oh, I thought you were talking about this.
No, this right here, I'm sorry. What is that going to be?
It's gonna be. You can't reduce it.
Nope.
It's gonna be forward.
There you go, KK. Now, common denominator then would be what? Yeah, so what do I have to multiply the second fraction by? The second fraction. Yes. 7 over 15 minus what? Plus. Can you tell me what that is? Yes. Girls, everybody all right over there on the fractions? I know it's annoying. We're not using a calculator. We're trying to make sure one last time. Everybody okay with that? All right. Here we go. Now you have to name the property. Uh-oh. Molly, do you remember the property name for number 25? Wow, thank you, kiddo. Good job. COMM of what? Are we adding or multiplying? That is correct. Very nice. Good job. Okay. So now, Jolie. Yes. Associative of what? All right, I like it. Okay, here we go. Wow. That's very good. Identity of multiplication. I'm pretty good with that. All right, Avery, bless you. Now, 0 property, Avery, means multiplying by 0, you get 0. So what's happening to the z and the negative z? What are they doing to each other? They're canceling each other out. So when things cancel, it's called inverse property. Inverse. This is called the additive inverse. called the additive inverse. When things cancel out, it's an inverse. All right, when they remain the same, it's an identity. All right, Ashley, what is 29 called? That's right, distributive property. All right, Luca, tell me.
Multiplicative.
Very, very good. Thank you, sir.
I just looked at it.
All right, good job. Thank you. Multiplicative inverse. That's nice. All right, you're supposed to use your notes. Good job. Now we're at what, Cole? Shh. Nope. Identity means you're staying exactly the same. All right. This is the what? Anytime you multiply by 0, you get what?
Oh, zero property.
That's called the 0 property.
I thought we were on the.
Well, the one above it's already written down.
I was thinking that.
All right, 0 property. Don't worry about it, buddy. I don't care. We're reviewing. All right, Eddie. Number 32. Associative property. Yes. Associative property of what, though? Of multiplication. All right, Tyler. Wow, why is it commutative?
Because the order switches.
Yeah, the order is different. Don't automatically put associative just because the parentheses are different, right? This commutative property of addition. Commutative property of addition. I'm happy with that. All right, here we go. Yes, stop playing around. 34, what is it? That is correct. Of what, though? Yes. All right. Now for 35, KK.
You skipped me down.
Oh, Jackson, go.
It's the multiplicative inverse.
That is correct. Multiplicative inverse. Again, notice if you're not sure, the 2x and the 2x are canceling out. That's why they call it an inverse. All right. Okay, now we have to go back to our sets. All right, so let's review real quick. In the little box there, squeeze it in. What does natural numbers start with? Who remembers? Jolie, do you remember? Yes. 1, 2, 3. All right, and then dot, dot, dot. Everybody write that in. Whole number.
0.
Yes. Whole number starts with 0. Is everybody agreeing with me? Remember integers?
Yes.
What?
-2, -1, 0, 1, 2.
Yes, -2, -1, 0, 1, 2, and then don't forget the 3 dots. All right, now who remembers rational?
Wait.
Tell me. Yes, right, any number that can be written as a fraction. Make sure you write that down. Any number that can be written as a fraction. Shh, 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 no. Hey, guys, come on, stay focused now. Any number that can be written as a fraction. So irrational is,
Number that can't be written.
right, any number that cannot be written as a fraction. Any number that cannot be written as a fraction. All right, that's what I want. All right. And then real numbers, we're going to say are
Anything but infinity.
all numbers.
Or negative.
All right, all numbers. Eventually, if you want to put on here in algebra 2, they will talk to you about imaginary numbers.
Infinity.
All right, they will talk to you about imaginary numbers. All right,
Infinity.
But right now, all numbers that we know about are real numbers. All right, did you write that out, KK? All right, so now, KK, I need you to tell me about the number 7.
It's natural.
It is?
Oh, wait.
Yep. Now listen, KK, I always tell people, once you check natural, natural is what? All of them, except which one?
Irrational.
Except irrational. You with me? As soon as you say it's natural, just like as soon as you say it's whole, it's the same situation. All right, so it's an integer, it's rational, and it's real. All right, so Molly, tell me about -2.
It's an integer
It is definitely an integer,
and it's rational.
and it's the last column is, yeah, the last column is always checked. So to save us some time, let's just everybody check out the last column.
Is pi imaginary?
No, pi is not.
E is.
All right, so here we go. Now I'm at Jolie, -2.875. What set does that go in? Integer has no decimals. So it's definitely not an integer. Shh. Now, listen. Also, if you forget, above rational, you can put decimal. All right, if it terminates or repeats, it's considered rational. Do you hear me? So now my question to you, some of my kids didn't know what terminate means. Do you know what terminate means? All right, so does that terminate? Huh? Terminate means it ends.
Oh, no.
Yes, that's what it means. Repeating would be like 0.3 repeated. All right, so because -2.875 is a decimal and it terminates, is it rational? Yes, it is rational. All right. And of course, we all are familiar with pi. That is definitely irrational. Pi is irrational. All right, Avery, 0.912 repeated. What set?
It's rational.
It is rational. Very good work. It is rational. All right, Avery, what about the square root of 36? I'm sorry, not Avery, Ashley.